Good afternoon and welcome to everybody to this new low carbon heating solutions for domestic or home properties. Delighted to have such a good turnout, and of course a terrific lineup of speakers as well. My name is Martin Garrett and I'm Chief Exec at Cambridge Cleantech. I'm just going to do a couple of things before we get on to those all important speakers. First of all, just a little bit on housekeeping, and then just one or two opportunities I want to mention which are upcoming in relation to the work that Cambridge Cleantech undertakes. So first of all, just a few pointers on housekeeping. Please remain muted. Although having said that, we do want to hear from you, so do use the chat facility which is in the centre of your console at the bottom of your screen. Just type away. Peter, who's really effectively chairing the event, Peter Bates, will either pick up on those questions if they're pertinent and immediate for the speaker that's speaking, or we can handle them in the Q&A and panel session at the end of the event. Please do also note that we are recording this event and it will be available on our website from tomorrow. And we also have Cynthia and Oriane from the Cambridge Cleantech team who are giving you a wave, just in case we have any issues or we need some help in any way. And there will be 3 breakout rooms that we'll be using at the end, and Oriane will explain more about that later. So that's the housekeeping done. A little bit of news on Cambridge Cleantech. Peter, if you go through to the next slide, please. So I always just like to mention a couple of upcoming things and opportunities that we're working on at the moment for our members. So first of all, we have our Cleantech Venture Day coming up on the 25th of March, towards the end of this month. We have 24 growth companies pitching to what will be a room full of investors. I'm afraid it's too late to actually apply to be a pitching company at the event because the deadline has passed. And we do provide some training for those companies that have been successful and that will pitch on the day. But if you want to attend the event and see all the latest technologies coming out of the ecosystem that we manage and organise, then that will be a terrific event for you. We have a couple of, moving on from that, in the centre of the screen that you can see there on the slide, we have a couple of Meet the Buyer events with large corporates. A brand new one has just gone on in the last half an hour from a Belgian company, and the one that you can see there on the screen is actually from Shimizu, who are a top 4 Japanese construction company, and they're looking for a whole range of different solutions in energy related to construction. So obviously a good link to this event in some ways as well. And then lastly, on the right hand side, there's another challenge that we put up onto our website from one of our partners. And this is Iberdrola, the big wind turbine manufacturer, looking for a range of solutions for their business. So just some examples of the types of events and the opportunities that we have for members for you to take a look at in the future. Anyway, I think that's enough from me. Let's move on now. I'm going to hand over to Peter, who's going to start to introduce the speakers and the agenda for the day and listen to some of the presentations. Thank you, Peter, over to you.
Okay, thank you, Martin. Yes, hopefully Martin is going to give a review of the budget and the green bonds and green homes grants that appeared in the budget. Sorry, I've just had a text message about that, so I'll leave you to delve into that one, Martin, if you're still around towards the end. Well, thank you. Welcome everybody to the 4th Sustainable Smart Homes Special Interest Group. We've been going since September last year. I managed to persuade Martin that it was perhaps a good idea and appropriate time to actually have a special interest group that focused specifically on the sustainable homes and how do we actually start to overcome some of the issues which are required, particularly for retrofitting homes and in order to meet the zero carbon emissions by 2050. I'll talk about the speakers in a few moments, but if I just very quickly kind of introduce and explain a few more things about the Sustainable Smart Homes Interest Group. Basically, we're looking at, as I was really just saying, sustainability and how we can actually deal with that and overcome those 2050 zero carbon targets. We're looking at smart solutions which are emerging and are going to be increasingly important to look at and develop intelligent home energy systems to encourage this meeting the targets. And we're actually focusing on homes, not commercial properties in this context. So we've got a large market, 27 million, maybe heading towards 28 million by 2030 properties that we need to deal with. So we've got a number of events coming up later, which were in the year, as well as this event, but I will explain more about that later. Can I also point you to the LinkedIn group? This is linked to the Cleantech special interest group, but not part of the group. There's the link there, but all you need to do if you're on LinkedIn is to do a search on sustainable smart homes, and that's where I try to kind of post various articles which are related around this space. So if I can just introduce the topic of today, oops, sorry, which is all about how can we decarbonise the home in terms of heating, because currently we only have about 5% of homes that actually have low carbon heating. I've had a 30-year-old boiler and I want to decarbonise my home, and I still haven't as yet found the ideal solution to actually do that in my 3-bedroom semi-detached property, which some of you probably would have seen when I actually used it as a case study in previous events, which, by the way, have been recorded and are available on the Cleantech website. We've still got something like 85% of heating is through gas heating, particularly in the winter time. And that's a big issue which does need to be addressed. We've still got, and we still have this problem of energy being wasted in homes for a whole variety of reasons. And it's pleasing to know that the past 2035 delivery mechanism is gradually addressing the whole issue of taking a whole house approach to improving properties, but dealing with fabric first. Now, we're not going to be looking at fabric first in this session, because we want to be looking at what new innovative solutions are there to create low carbon heating solutions. And we must bear in mind that half the population don't have any awareness of low carbon heating in any respects. The main solution currently appears to be air source heat pump, and possibly a ground source heat pump if you actually have the space. It is certainly something which has been encouraged by the government in terms of the Green Homes grant funding and the renewable heat incentive funding, the latter of which has been going for a few years now. But I've been looking at this seriously for my own home. I'm not totally convinced it's appropriate for my own home, and for that matter, I don't think it's the only solution which is going to be needed in order to reach carbon zero excuse me, by 2050. And there's a lot of issues around there. It is claimed to be very efficient, which is a big advantage of air source heat pumps, but that efficiency does drop in winter when we most need the heating. One of the other biggest problems is we actually have to have installers who are experts at getting this sized up correctly and trying to avoid it being oversized according to the occupancy needs. Although admittedly, I understand that occupancy needs do change over time. And another issue I've discovered is, in fact, and I go around a lot of houses doing energy assessments of people's properties, is that in fact they need to be controlled correctly that way, and as well as being complex to install. So air source heat pump is a very appropriate solution in certain contexts, but we do need other solutions, simpler solutions perhaps, which actually are easier to install and still provide a more efficient way, or almost as an efficient way to provide heating as and when required by the occupants of the house. And obviously every single house is different. Every single house has different occupants, has different needs. Some people like to turn up their temperature to 25 degrees. Some people want it down to 18 or 19 degrees. That must be easily controllable as well. So we have three main speakers who are who've come up or are developing various solutions around this space, and they'll be talking in a few minutes. We also have Claire from Woodvines, who are solicitors, I think, and Claire's going to spend a few minutes at the end of this session talking about what small and medium enterprises need to consider when they're coming up with innovative solutions and getting themselves established as startups. So I'm going to now move on directly to James, who is, if I stop sharing the screen, and then he can take over. But before I do that, if I could just explain the chat and the opportunities for asking questions. We're going to allow up to 20 minutes for each of these speakers, but that would include 5 minutes towards the end for questions. So there will be an opportunity at the end of each of these speakers for some of the participants, if you put a question in the chat. But when you put a question in the chat, to make it easier for me to see, if you can put it in capitals question, if it's addressed to James, put it to James, or if it's to anybody, address it to the panel on there, then it's easier for me to pick out where there are relevant questions to do there. So that'll be the first opportunity immediately after there's been a speaker. Then we'll have a question and answer panel session, which will last roughly about 20 minutes. And then the third opportunity is that everyone will have the opportunity to go into a breakout room, and we'll list the breakout rooms later. So James, Christine and Johan, the three main speakers, will each go into a separate breakout room, and they will be, you will be able to join that breakout room. And basically the whole idea is to simulate a face-to-face kind of event where participants congregate around the speakers and kind of ask some individual one-to-one questions in that respect. So three opportunities. So if you don't get the opportunity, or I'm not able to pick out a question during the main session, there will be that opportunity to ask a specific question to one of the speakers, which occur there as well. Okay, so if I can now pass on to James, if I will stop sharing the screen at my end, which I have now done. If James, you can share the screen at your end.
Lovely. Can everybody see that okay?
Yep, that's fine. That's okay.
Okay. Perfect.
Go ahead, James.
Peter, thank you very much, and thank you to the team. I'm James Norton, CEO of Caldera, and I'm here to talk about how we can make heating your homes green with our Warmstone heat batteries. I will say, I suspect Johan from TPO and ourselves, we have similar philosophies around heat batteries and thermal storage. So I'm hopeful that our two talks will be complementary to each other, because we're fairly well aligned in our thinking about how heat batteries fit into the grid. Oh, let's just click on this. There we go. So as Peter said, over the next 30 years, we pretty much need to convert the whole UK housing stock, around 1 million homes a year, to low carbon heating. And at Caldera, we're looking to tackle the difficult homes. And I do find Peter's introduction very helpful, because a lot of the problems he's describing, those are the sort of homes we're aiming for. Our patented Warmstone heat battery, it stores renewable electricity as high quality heat for use on demand by the homeowner. And we're designing it as a direct replacement for an oil or gas boiler. So you shouldn't need to make changes to the fabric of the building. And driver for this, we've got to get to net zero by 2050. And we have a particular focus in the short term on off gas grid, predominantly because we're more competitive against oil and LPG. As Peter said, gas is very hard to compete against at the moment. And until there is a sort of significant shift in government policy, we're very much focused on homes that are using heating oil and LPG. And for those homes, the low carbon approach is predominantly heat pumps. And when you sort of look at the other, so that there aren't really that many other options beyond heat pumps being pushed. And these off-gas grid homes, they are on average older, larger and less well insulated than homes that are on the gas grid. And this is the problem. And Peter's gone to it again, but heat pumps work well in, and I say new properties, I probably should say well insulated properties. When you look at making an older property suitable for a heat pump, depending on the age of the property, you could be looking at a bill of between £20,000 and £40,000. This doesn't add particularly to the value of the property. It's deeply disruptive to the homeowner, and there often aren't any better alternatives. So you end up with people simply going to replace their existing boiler with another boiler, even though they really want to do something that is low carbon and green. And this is part of the issue. We have very old housing stock in the UK. So 7 million of our homes were built before 1930, and they all have solid brick walls. The ones after 1930 are better, but they're not great. And even today, and I feel quite strongly about it, I believe new build homes should be built to much sort of nearer passive house standards than the current building regulations require. It's so much simpler to do it when you build a property to make it well insulated than it is to do as a retrofit. And retrofits are really difficult. So between 2008 and 2017, there were a lot of initiatives to improve the fabric of buildings. And you can see how everybody tackled the cavity wall insulation and the loft insulation, and all of the homes with solid walls got left alone because they're too difficult. And when you look at how far we've got, you suddenly find, oh, well, look, we actually tackled 70% of the properties with cavity walls. We've tackled 70% of the properties with loft. We put loft insulation in. We haven't even got to 10% with the 7 million homes that have got solid walls. So that's about a quarter of the housing stock. And it is much harder to treat for a number of reasons. So when you look at solid wall insulation, you might have bought a home because it looks beautiful, because it's old. Well, you don't want to insulate externally, but then if you go internally, you potentially lose a lot of room space. So there aren't, and people often just keep going back to saying it doesn't make sense financially. And I can talk a little bit more about that, but we're aiming to help these sort of properties because our approach is we're after net zero carbon, we're not necessarily after low energy. And often those 2 points get conflated together, but the aim is if somebody is using zero carbon energy and they're using more than a home next door that's also using zero carbon energy, we've still got to where we wanted to get to, which is net zero. So this is our solution. We call it the zero carbon boiler. It uses our warm stone heat battery, and I'm standing next to the unit that's heating my home at the moment. And it stores 100 kilowatt hours of heat. So that's about enough for a 4-bedroom home in winter. For 24 hours in the summer, it'll provide at least 7 days of hot water. And that's partly to do with the efficiency, which I'm going to talk about in a little bit. We're very keen that it has the same characteristics as your normal boiler. So this outputs at 30 kilowatts. And we've got a target installed cost of £10,000. And if I was to do 100 kilowatt hours with lithium ion batteries, you'd have a bill of about £70,000. So what do you get for your money? What would you get for your 10,000? You can take out your oil boiler and your oil tank. Your cost of energy, if you can get a 5p overnight tariff, your cost of energy will be the same. And your carbon emissions from oil will halve overnight. And over the next 10 years, they'll drop by 90%. So there's a big carbon saving straight away from switching to electricity. And then the second point is minimal disruption. We use the same plumbing that your boiler uses. So if you need 75 degrees C water because it's an old property and it's got small radiators, that's fine. We sort that out. So we're looking for really the minimal disruption to the homeowner. And lastly, if you've got solar PV, in the summer we can store excess, so you can use it for free hot water. If you go on holiday, we'll store it for a week. We can shift into weeks, as you'll see in a second. 3 components to our product. We've got the warm stone heat battery. It's about 1 metre in diameter, allow 1.7 metres high. It's located outside the property or in a garage, has an electrical supply, and then in your home we replace the boiler with a heat interface unit, which is basically comes from a district heating network. So standard bit of kit, same functionality as a boiler. You shouldn't notice the difference. So at Caldera, we've focused very hard on two things. One of them is efficiency and one of them is power. I've talked about the power earlier. We think it's really important that people are used to, I've tried heating my home on 15 kilowatts and it takes ages to heat up because I've got my hot water cylinder on and I've got the heating on and it just takes a long time, and it immediately you feel the difference. So power is important. We've also done a lot of work around efficiency, and we use sort of ultra efficient vacuum insulation, and at high temperatures we've had to spend a lot of time developing this because it's hard to make, and we now have a system where our average loss is around 220 watts. So for your home using 16,000 kilowatt hours a year for heating, it's going to be 90% efficient. You'll lose about 10% of that. Couple of nice pictures taken with our thermal camera. There's me standing in front of the unit, the warm stone core, which is inside. It weighs 1.3 tons and it's at 480 degrees C. It's a lot cooler than me. That's probably not hard actually, but bad joke. But there's my trusty tea mug. You see it in the picture here. But that was at 70 degrees. My face is a lot hotter. The outside of the vessel is at 6 degrees above the room temperature. And when you're going, we operate the warm stone core between 500 degrees Celsius and 200. And because we have a high temperature, it allows us to get lots of power out and it allows us to provide hot water. But to cool from 500 to 200 degrees C takes 19 days, almost 3 weeks. And I'm sure in time we will get over 3 weeks. So if you're away for a week, we'll store the solar energy. You hopefully come back to a nice full tank in the summer. So there are a number of things that heat batteries can do that are really important, and we see ourselves as complementary to heat pumps. For homes that you can use less energy because you can fit a heat pump, use a heat pump. There will be a range of properties though where they're not, to my mind, they're not the right solution. And I just thought this was a picture produced by National Grid just showing the issues they were having managing low demand last summer, or it was actually around Easter. But you can see the UK grid varies from about 15 in the summer to about 28 gigawatts. In the winter, it generally varies from about 30 to 50 gigawatts. If we installed 1 million of our units, we would give the grid 20 gigawatts of demand response for 5 hours. I couldn't get that on the scale here, so I've doubled the width, or we give you 10 gigawatts for 10 hours. And that's 5% of the housing stock with heat batteries. And suddenly you can start to move demand around to when renewables are generating. It supports the grid because you have the ability to drop demand off or bring demand up on, at will. But it also supports the rollout of renewables. If you can't, if the electricity price goes to zero all the time, people will stop building renewables or the cost of it to the government. So by actually being able to fill in the gaps around when heat pumps are working, tend to be in the morning and the evening, we actually support the grid and we support the rollout of renewables. And another point, so this graph here, I'm afraid I produced it. Everybody tells me it's difficult to understand. The dotted blue line, that's the carbon intensity of a natural gas boiler. So it's 215 grams CO2 per kilowatt hour. You've got 2 days, this was last October, I think, you've got 2 days of grid carbon intensity and 2 days of wholesale prices. So you can see the blue line, which is the carbon intensity of the grid, varies from about 80 grams up to almost 240. So even within a day, the carbon intensity can vary by a factor of 3. And also you can see how the wholesale price and the carbon intensity move together. When there's lots of renewables generating, carbon intensity goes down, the price goes down. So we will be charging in the blue bits, and you would normally expect a heat pump running a home to be operating in the red bits. So even if the heat pump has a COP of 3, we're going to have the same carbon intensity and we're going to have the same price difference as well. So, I don't know what the right ratio is, but to me, there will be some ratio between thermal storage heat batteries, electric vehicles, which do the demand side response, and heat pumps that want to operate when people need their heating, which is predominantly in the morning and the evening. So we see ourselves as very complementary to moving the whole shift towards more wind generation and more solar. There are a few regulation issues, so I haven't had a chance to review the budget, so I'm afraid I may be missing things. We would like heat batteries to have equal grant status with heat pumps. So if you're going to subsidise heat pumps to go in, we would like a similar subsidy. If we don't get the subsidy, then in a sense, it's harder for us to compete. In fact, it distorts competition. So first thing we want from the government generally is equal technology status rather than picking one technology and effectively making it harder for others to commercially succeed. That also goes for VAT status. Currently, heat batteries attract 20% VAT and heat pump attracts 5%. And then within the actual electricity, within the electricity market and the electricity and gas market, there are two pricing structural issues. The first one people are aware of, and the reason we don't compete against gas at the moment, which is gas is effectively subsidised and electricity is effectively taxed. So there's a very big discrepancy between the two in terms of pricing. And then there is a separate issue that is related to electricity only, which is that there's a lot of social charges to do with renewables that have been installed on the grid already. So CFDs, FITs, ROCs, that's added on at a fixed rate to each unit of electricity. And the network costs are also added on broadly at a fixed rate. And that makes no sense. If a wholesale price is zero and the grid is not loaded, you shouldn't be applying these charges as a flat rate. So we believe that you need to move to a much more flexible rate where these charges are also reflective of the wholesale price. And when you have fixed charges, you tend to find that you have a flat spread between day and night, which will favour heat pumps. Excuse me. Whereas actually, if you want a properly flexible grid, that reflects the wholesale price, then you would move much more to the sort of structure we are, where you might be able to buy electricity as a customer for 1 or 2p, which is better than it being wasted and thrown away, than at the moment where even at 5p, you're just about covering your costs. So to me, there's a number of regulation issues which we hope will get resolved over the next 5 years. Ofgem seem very aware of a lot of the issues about how do you integrate renewables. And I say to people, if you don't incentivize people to move demand, they won't bother. So you need to put pricing structures in place to encourage people to move when they use electricity. And then just about us, we've got patent granted on our warm stone material. We've got more patents being filed. We've had £1.5 million invested in the company. We've had a lot of support from Innovate UK, Bays. I'd like to say thank you to Energy Systems Catapult. We're part of their launch pad, working with a big social landlord called Places for People, who manage 200,000 homes. And you can see our manufacturing premises in the picture. We've got a unit working well in my home and in the factory. Jobs we still have to do, we need to complete certification of that. We want to run bigger pilot trials in homes this winter. And this is a definite little pitch. We are fundraising, so if anybody is interested, please contact me or direct message me separately. But very happy to answer any questions.
Thanks a lot, James. I'm just putting my video up again. Yes, we have actually had quite a few questions come in. I think you did make a very relevant point about the balance between gas and electricity, and the fact that it's weighted in favour of gas at this present moment in time. So that was a very good point. Couple of questions here from Matt Barr. How does vacuum insulation fare over years?
It depends upon how you do it, but we are confident it will last the full 20 years.
Okay, good. And there's one from Nicola Terry about the Homely device. I don't know whether you've come across the Homely device.
Homely?
Homely, yeah. It is actually it's a device which you can put onto an air source heat pump. It's come from a company who are based in Manchester. In fact, they are speaking at the next event on the 22nd of April. So if anybody wants to know about the Homely device, come to the next event or book in for the next event. That's a nice plug for me. But the question was from Nicola Terry, is how can you use this to optimize the heat store? As you're not familiar with it, what it basically does is it can take electricity flexible tariffs like Octopus Agile, and then adjust them according to the cheapest time to do this. And we actually have Phil Steele from Octopus Agile is listening in at the present moment on that one. So maybe there's an opportunity for you and to chat.
Does the device store any energy, or does it just shift when you switch the heat?
No, it basically kind of as far as I understand it, it actually takes the identifies where the cheapest Octopus Agile. It is Octopus Agile at the present moment, and I can see Phil is nodding while I'm saying this.
I can come off mute if you wish.
In fact, Phil, go and speak.
Just very quickly, if you watch my waving my arms around, the homely thermostat sets a lower threshold and an upper threshold, and when the Agile rate is low, it'll heat the property to the higher threshold, and when the Agile rate is high, it'll let the property cool down. With your device, you'd be charging up on the lower Agile rates. The homely is used more with, say, an air source heat pump. They've done it with Nebe, where you've kind of got that real-time control of a device. You'd probably use it less with a storage device like yours, because you're storing off-peak, probably on go between midnight and 4:30, rather than needing to use homely managed thresholds like that.
Well, I think I'll probably say a longer term view is that most homeowners don't want to control when it's charged, and we're expecting utilities like yourself to give them a special rate for the heat that goes through it, and you'll then just switch it on and off, and exactly. They'll never have to think about it. That's the plan. Yeah. And from a grid perspective, it makes much more sense because you can monetize that value much better than the average homeowner.
Yeah. So for what you're doing with storage, homely is actually less relevant.
Okay. Any other questions, Peter?
Yeah, one quick question. There's a number of questions come through, but we'll have opportunity later on to talk about this. Quick question here from Rod. What is the operating cost per kilowatt hours?
By operating cost, okay, well, it depends on the electricity price. So if you buy it at 5p, you're going to lose 10%. That's the view. So it costs you 5.5p to go in, and we're expecting it to last 20 years. In terms of maintenance, my expectation is every other year. It's not a gas boiler, there's nothing to sign off, and it's really not very complicated. My unit was installed by my plumber and electrician.
Thanks a lot, James. That's great. We'll move on to our next speaker. Just before I pass over to Christine, just to remind people that when you received the email about 2.5 hours ago, there was an opportunity to ask a couple of questions. If you can go back to the email and just ask a couple of questions, and we'll get the results of that.
Peter, I'll just send the 2 links on the chat. So if you haven't done it yet, it's in the chat now.
Thanks a lot, Ariane. Okay, Christine, if we can have you stop sharing. You've stopped sharing, James. So Christine, could you share your screen? And then it's over to you. Okay, I can see your screen, Christine. Great. You're on mute, by the way, Christine.
Okay, you can hear me and see me?
Yep, great. Thanks, Christine.
Good evening, everyone. Thank you very much for the invite and for organising this, Peter, Martin, and the rest of the team at Cambridge Cleantech. So my name is Christine Boyle. I'm the CEO of Synergy, and we've developed sustainable solar thermal that will be a real game changer for solar heating and cooling. Down a bit. Oops. So your game of choice may be chess, poker, or even computer gaming. But for Synergy, we're in the game of solar heating. And in every game, you have to engage with the code and change the game mechanics. So let's start with the code. This is the instructions and information we use to understand solar thermal. In April 2010, the feed-in tariff scheme for solar PV came into effect, which was initially set at 48.29 pence per kilowatt. A very generous incentive, and it distorted the solar energy market in the UK setting the solar thermal market on a continued decline. And you can see here the damage that this did to the solar thermal sales from 2010 onwards. Solar thermal did of course have the renewable heat incentive. However, solar thermal deployment under renewable heating incentive has been restricted due to only being used for taps and baths. So we weren't able to use solar thermal for space heating. So in terms of SAP 2012, which is the government standard assessment procedure for energy ratings of dwellings, the market for solar thermal was significantly limited. Imagine if heat pumps could only be used to heat bathrooms and no other room. Or imagine if solar PV was only allowed to power your television and nothing else. SAP 10.1 was then introduced in October 2019. And this graph shows under SAP 10.1 that if we increase the solar thermal collector space from 4 meters square to 10 meters square, we can improve the energy efficiency performance rating from 3 up until 7. Cheap gas prices haven't helped either. In the UK, gas prices are relatively low, and this encourages the use of gas as the main fuel for heating. The UK has one of the biggest fossil fuel subsidies, resulting in low gas prices, half the price of, say, Spain, Italy, France, and this does not incentivise the shift to renewable heating options. But the solar thermal industry have engaged with the game, and they've attempted to change the instructions and information we use to understand solar thermal. SAP 10.1 now includes solar thermal for space heating. SAP 10.1 uses more realistic carbon emission factors, which gives solar thermal a benefit. And we now understand that heat pumps do work well with solar thermal and PV. And a gas levy will of course ensure a more rational gas prices and level the game's playing field. But more work needs to be done in terms of schemes to drive the adoption of low carbon heating. Government is beginning to understand the schemes like the Green Homes Grant must work for consumers, installers and manufacturers within the entire supply chain to deliver solar heating into our homes and workplaces. More work needs to be done. In terms of schemes to drive the adoption of low carbon heating, government is beginning to understand that these schemes like the Green Homes Grant will deliver. Additionally, as manufacturers, trainers and installers of new heating solutions, we have a responsibility to stop focusing on flashy brochures and to focus on our energy on locking in quality standards within the entire solar thermal supply chain. If countries like Austria have recognised the value of adopting solar thermal to reduce carbon emissions on this scale, so can the UK. In Denmark, they've proved that with scale and seasonal storage, they've reduced the cost of solar heat to between 2 and 5 cents per kilowatt, proving that we can compete on price and we most certainly can compete on carbon. Now for the mechanics, the tools that we use in the game to deliver rewards and effects. For those of you waiting of the answer, we were going to do a survey to ask what you thought, what was the percentage of heating that we use for heating in our homes and workplaces. The answer is 78% of the energy in our homes and workplaces goes to hot water heating, space heating and cooling. Solar thermal is one of the most efficient heating technologies. It produces 3 to 4 times more power per square metre than PV does. Solar thermal is generated on-site off-grid, reducing the need for expensive infrastructure. And water is one of the most efficient and least capital-intensive mediums of energy storage. However, the current technology behind solar thermal has limited its widespread adoption and its contribution to decarbonisation. Current thermal panels are made of glass, copper and aluminium, carbon-intensive materials that make them expensive to manufacture. They're heavy and bulky, which makes them expensive to install. They're not architecturally attractive. There have been challenges integrating them with both the building envelope and other renewable technologies, such as heat pumps. And the value of this technology to the customer is not clearly understood. For all of the above reasons, solar thermal has mostly been used just to provide renewable hot water and not to deliver space heating and cooling, which is where we see the big opportunity. Let me introduce the Senergy thermal panels, made of 100% advanced nanocomposite materials, which are primarily polymer and plastic, and suitable for mass production. They're 50% cheaper to manufacture and install than current metallic panels, with 150% less carbon in production. The lightweight, low-cost panels make installation easier, faster and cheaper, allowing greater numbers to be deployed on the roof, enabling us to feed this energy into not just hot water, but also space heating. They give the architect much more flexibility with design, and we have a user-friendly digital platform which drives increased performance, lowering the cost of delivering a kilowatt of solar heat to a price point that will compete with gas and oil. In comparison to other solar panels in the market, Senergy provide the lowest cost, lowest carbon solar heat energy. So currently we're really working with our early customers, and we're focusing on locking in our entire supply chain. And we see that this is absolutely crucial, beginning with the material suppliers, through to our polymer manufacturers of our panels, through to the heating system partners that we partner with in terms of delivering the systems, through to accredited trainers that will bring about our accredited installers, ensuring that we deliver the same high standard installations that will keep our pilot customers happy. And it's crucial that we create a highly skilled workforce at every stage of the supply chain, because this is the foundation required if we deliver and maintain the low carbon heating solutions of the future. And this is the prize. This is the result when we deploy large scale solar thermal with large scale storage. We get greater cost savings, and you can see greater carbon savings. Another example of solar thermal used at this time for cooling, and these projects highlight the opportunity we have, particularly in areas where land is not available or extremely expensive, particularly in urban areas, and roof space becomes valuable. I hope I've outlined the opportunity for solar thermal to enable us to build back better over the next decade, and really happy to take any questions later. Thank you.
Thanks a lot, Christine. We've actually got quite a bit of time left now, which is great. You raised an important point that, and I don't know whether you actually are able to find any way forward in this. In fact, under the renewable heat incentive, currently your solution is not eligible for that. Are you seeing any potential kind of movement between from government in making your solution available under the renewable heat incentive, or the revised version of the renewable heat incentive from April 2022?
We are to date are funded by BES, so obviously they're keeping an eye on exactly what we're doing, and we're feeding into the decision makers in terms of policy going forward. So we'd like to see that when they see the innovation coming forward, that they align the policy going forward to that, particularly if they want these technologies to be taken up and to be scaled. I think the important thing is that within domestic use, renewable heat incentive is still optimal for our technology. I think when it comes to more industrial use, there has to be more consideration to the solar thermal technology and policy alignment with industrial use.
Okay, yeah. So just to clarify, would your solution be eligible under the renewable heat incentive? My understanding is it's not.
It is at present under domestic.
It is available under the domestic,
yeah,
because it can include space.
That's correct.
Heating. Right. Okay. I've got a question from Rod. What is the estimated cost per meter for the panel?
So we plan to sell the panel at exactly the same price as the lowest cost Chinese panels are coming in. So it's not really about the price of the panel. It's more what we are focusing on is the price of delivering a kilowatt of energy. So if we can deliver at a price that competes with gas and oil, then the panel will be sold at the
Okay,
best
right.
price for Synergy.
Okay, thanks, Christy. A question from Paul Hatfield. I'm just going to read it out. Hopefully it makes sense. Heating is needed chiefly in winter when solar thermal is generally unable to supply even all of the hot water for the home. How can solar thermal supply more in winter than at present in order to provide sufficient space heating as well as domestic hot water?
You're absolutely right. Storage is key, but then that's why we talk about integrated, and that's why we came up with Synergy panels, because it is the synergy between the different technologies combined in hybrid solutions that'll win the game at the end of the day. So it'll depend on each project. So it may well be that if it's a new build, well insulated home, then you'll have enough in terms of diurnal storage, and that most of your hot water and heating supply will actually be needed into your showers and taps. If it's a hard to heat older property, it could be that Synergy thermal is combined with solar thermal, and that is an optimum solution. It could be that the gap in the winter months is made up through low cost electricity, giving you the top up of heat supply. So each project is individually needs to be designed on its own merits, and the technology needs to fit from design stage. And again, that's where we're working with the Energy Systems Catapult. And when the useful thing is there that most of the properties in the UK are replications, so they were all built, whether it be the 60s, 70s, 80s or 90s. And when we get a solution for one of those buildings, it's just a matter of extrapolating that solution out for the rest of the supply chain.
Okay, thanks, Christy. Perhaps we can, Oriane, can we have the results of the survey?
I'll start sharing my screen now.
I'll let Christine comment on the results, because.
Okay, here are the results from the questionnaire we had earlier.
Can you just read out what the results are? Because to be honest, I can't see too easily on my.
So the first question was, do you know anyone who uses, it's the wrong one. The first question was, what percentage of the overall energy usage for the domestic property is used for heating only? And almost 70% of the attendees replied 70%. And then we had a little less for 50%. And only a couple of people replied that 25% of the overall energy was used into for the heating. Christine, do you want to comment on that one?
It's a very informed audience, is what I would say. So yeah, most people are aware that there's a very large percentage of our energy bills goes on hot water and heating, and obviously that's where our real challenge lies.
And so the second question was, do you know anyone who uses solar thermal panels? And it looks like, because the first three answer were basically, yes, I use it, or I know one or multiple people who uses it. It looks like, again, the vast majority of the attendees either know someone or have solar thermal panels.
And that's really good to know. Again, I know this is an audience who are obviously very much swayed towards renewable technologies and have been using renewable technologies, and it probably isn't a snapshot of the rest of the population, unfortunately, but it's great to see that people do have solar thermal on their agenda.
I just got another question coming in. Again, there's a few questions I haven't actually included yet, and we'll use those in the question and answers, but one's just coming from Alex Marshall. How does the efficiency compare between solar PV and solar thermal?
And I wish I had a slide to show you the exact proof of that, Peter, but that's something that we're doing over the next 6 months. And with our demonstrator pilots that we're actually working on at the minute, and then we really want to prove I mean, from our simulation and modelling, we think that we should very much prove that on-site, off-grid, taking the pressure off the electricity grid, a thermal option will be a much better solution. But in different cases, different horses for different courses. In some instances, PV and battery will win out. But yeah, we very much want to give a proof point. So I'm hoping if I come back here in 6 months, I'll be able to show you a slide that actually proves that solar thermal and storage does work on both cost and very much on carbon as well.
Yes, I think that's an important point. I mean, I've had solar thermal in its kind of original format, shall we say, for about 18 years now. And I can certainly say for my own house, 3-bedroom, semi-detached house, for roughly 6 months of the year, I don't need to put on my gas boiler in order to heat up my hot water. There's the occasional day or there's a few days when it gets really quite, touch and go, but for roughly 6 months a year, I don't need to put on my gas boiler. And probably for then another couple of months either side of the kind of summer season, I'm probably only putting it on for half an hour of the gas boiler just to top up my solar thermal. So as a technology, I think it's certainly kind of, is a underappreciated technology in many respects. So yeah, that's good luck with your experiments and proof of concept in the next 6 months or so in that respect. Thank you, Christine. If I move on to Johan now, if hopefully you can share your slides.
Yep, no problem, Peter. Let's do that now.
Okay, I can see your slide. Do you want to put it in? Okay, brilliant.
Yep.
And I can hear you, so over to you.
Does that look about right?
Yep, brilliant.
Brilliant. Okay, thanks, Peter. Well, good afternoon, everyone. My name is Johan. I'm the CEO of Tepio. And I'm going to tell you today a little bit about our ZEB, zero emission boiler, that we are developing. I suppose I should first start by saying thanks to James for speaking first, because he actually takes a lot of the things out. Well, in fact, Christine as well mentioned quite a few things that I was going to talk about. So I will try and complement some of the things they say and spend less time talking about other things. So just, I suppose, first off, we've heard a lot about this already, but heating uses a lot of energy. 80% of the energy we use in our homes is for heating, and you guys have seen some of these stats now already during the course of today. The challenge is most of it's coming from fossil fuels still. But the question I need to ask you is, how are you going to heat your home? And Peter, touched on this earlier. Peter, how are you going to heat your home when boilers are banned, and how are you going to get away from a gas boiler? We need to stop using fossil fuel boilers. That's clear. And increasingly, the option is electrification, and everything is pointing to electrification. Thankfully, the carbon intensity of the grid has dropped by 50% just in the last 8 years or so. But I'm sorry to say that was the easy bit, and we barely noticed it. But actually, the really, really hard bit is going to be getting to net zero. And from a heating perspective, that's for two key reasons. Firstly, there are really massive challenges to managing an ultra low carbon intensity grid as we electrify everything and more things are using power. And secondly, because we've seen over the last number of years, heat pump sales are flat, and that's despite a pretty aggressive subsidy. Now, I've got nothing against heat pumps. I think they're a brilliant technology, but they are best used in the right place in the right circumstances. And they will not be suitable, I'm telling you, they will not be suitable for all homes in this country, and we need to have another solution. I'm going to talk a little bit about, because I thought this audience might appreciate a little bit more than the average audience, but hopefully I'm not wrong, a little bit of the 4 key challenges that I see around the zero carbon grid. We've spoken a little bit about volume today. So the volume of energy that we need from heating is obviously massive, and to convert all of that from fossil fuels to electricity, it's just the quantity of electricity is quite high. That we know. But there are 3 other really, really critical issues that are actually arguably more challenging, because you can build more and more wind turbines and solar plants. But actually the real challenge is around flexibility. So we've spoken a bit about that. System stability and inertia. This shows one of the turbines up at Drax, but but really the inertia that these really large centralized generators give to the grid is really valuable. And in a world where we don't have that, we need to provide that in some other way. Otherwise we get really big distortions at a very short period of time. And the fourth issue is around network constraints. And this is just the screenshot just around our office in Maidenhead. And I think 3 of the 4 transformers are heavily constrained. And that means that effectively the copper and the transformers are limiting our ability to get more power through the pipes in simple terms. So we've developed a zero emission boiler, ZEB, and we actually think this is going to be the simplest and cheapest way for people to stop burning fossil fuels. And most importantly, it supports some of these challenges that I've just been talking about. So a ZEB is a plug and play boiler replacement. It sort of connects to your existing heating system. You take out your boiler, you put this in its place on the floor, somewhere else in your home, wherever you want, and it connects into the existing heating pipes. So the same copper, we connect it up to the fuse board, and it combines direct electric heating with ultra high density dry core thermal storage, about 40 kilowatt hours of of usable thermal storage. And what we're able to then do is to flexibly control this storage capacity to do a number of things to optimize for any number of data inputs, like a real-time carbon intensity of the grid, flexible pricing like the Octopus Agile tariff, for example. We're able to support self-consumption of local renewables and PV. And we can also provide these really short-term frequency response services. Each ZEB has its own onboard revenue grade metering and frequency monitoring, and it can respond in literally a 1/10 of a second. So what happens inside a ZEB's brain? Well, as I've sort of touched on, every ZEB connects to the internet over our IoT infrastructure. And we receive real-time telemetry about the performance, about every component on the ZEB, how it's performing. And then we use machine learning to actually develop a demand forecast for your home. Each individual home is different, as we know, but the machine learning algorithm will pick up the heating demand over time and build a really accurate forecast for when you're going to need heating, and build that into this algorithm of when we should be charging the ZEB. So on the right there, you can see this is an example of a 3-day period. I think this was towards the end of December of a ZEB actually in a house. And you can see there how the state of charge of the ZEB is fluctuating over a 3-day period. And the heating consumption is there in blue. And actually this particular ZEB was on the Agile tariff. So thanks, Phil actually paid the customer on the 2nd day of this period, not himself. But we were actually able to get a net negative price for this customer on this day because of this flexibility. So these ZEBs are actually heating homes. I think there are actually 9 photos here, but we've got 10 as of today that have been heating homes throughout the winter period. We've left the existing boilers in place for our performance trial, and they're valved off. We put them on for a week or so at a time to get relative performance data between the gas boiler and the ZEB. And there'll be an interim trial report in the next couple of months. So I want to explain a little bit about why I really think a ZEB is a win-win-win situation for us. In terms of cost and convenience, I've touched on it. Easy installation. One of the biggest challenges to getting to high high penetration of things like heat pumps is the skills base, retraining of existing installers to understand how to install heat pumps. We have none of that. We've installed it with using existing heating engineers with no more than a very simple installation manual. There are no radiator, thermostat or cylinder changes required, so you keep exactly the same radiators. It talks to the same thermostat, so over open therm if you have that as well, and to your existing hot water cylinder. It's about 50% cheaper than a heat pump up front. And actually our modelling is showing that we can reduce the running costs to about 20% less than a heat pump, and that's because of the flexibility that we have. And the other thing is this is a product which is particularly suited towards smaller homes, flats, 2-3 bed houses where often there isn't the space to put a heat pump. And this is one of the big challenges that we have. And lastly, there's no annual gas certificate, which is obvious but important. In terms of carbon, there are obviously no local emissions because we're not burning anything. But actually, the indirect emissions, are significantly lower than even a heat pump, potentially, because we are able to optimize for the carbon intensity of the grid. We can self-consume renewables, and we've done an independent analysis to validate the carbon savings of the product. And lastly, in terms of the societal benefits, various people have done modelling to show the huge benefits from thermal storage. Imperial and the CCC themselves have done this. Whatever the number is you pick, it is large, and I think that is being overlooked. And that's because of the huge benefits we can bring around system balancing and flexibility in system and frequency response and that sort of thing. Look, it's a huge market. There are 1.8 million boilers sold every year in the UK of gas and oil boilers. They need to be something else as quickly as possible. We're working with energy suppliers, we're working with Octopus, with OVO, with EDF, to help bring this to customers. We think that it's an ideal route to market because ultimately energy suppliers are best placed to leverage some of this flexibility, and we can help things like supporting their short-term trading positions and that sort of thing. And then in terms of the proposition, we've spoken about the sort of the one-off cost, which is about half of a heat pump, so about £5,000, and then a subscription fee, which will cover price basically at the same price as a British Gas boiler cover, but will cover all your monthly maintenance, but also all the optimization stuff we do, and a whole load of other really cool insights and services that we are able to bring to customers, which we will be talking about over the next few months. Bit about the team, but you've seen me, and we have raised about 1.65 million to date. We've just started another fundraise, which will be closing in June, and we've been working with various different parties, but yeah, there's a long road ahead, and we're hoping to launch in the end of this, the first products at the end of this year. I think that's what I was going to say for now.
Thanks a lot, Johan. We've got one question come in from Rod. Electric storage boilers have been around for ages. Usually they're expensive to run. How is Seb different?
That's a very good question. Yes, they have. So the concept of dry core thermal storage has been around for decades. In fact, I think GEC sort of designed some of the first ones in the 60s. So I suppose we have a patent that's currently pending for the way that we're able to control the heat release from the core of the boiler into the water system. But really importantly, the other advantage we have over all of these old technologies that don't exist anymore or aren't around anymore is modern electronics, the internet, access to flexibility. And I suppose there's this misnomer that they need to be expensive to run. They were expensive to run. They were expensive to run in an old world where we didn't have flexible pricing. We had a basic overnight rate that was really designed to get rid of nighttime nuclear energy. We have a very different world now. We have very, very short-term demands of the grid and managing flexibility. We have dynamic pricing, such as the agile tariff, and we have a world we need to electrify heating. So yeah, we can bring the cost down of this to something which is comparable with certainly with an oil boiler.
Right, thanks, Aki. Thanks, Johan. There is another question. It's actually for James and Johan, but perhaps Johan, you can give your answer first. What is the maximum charging power of your devices, and what is the minimum time off time it can deliver on the peak day? If I just read that out again, what is the maximum charging power of your devices, and what is the minimum off time it can deliver on the peak day? That's a question from Lucas Bergman.
I think I understand the first question is easy for us. I don't know what James is for this model in particular of the ZEB. It's 9 kilowatts, 9.4 kilowatts electrical in, and the power output is 15. And I think the second question is asking what's the longest period we can not be charging for on a cold day. That is an impossible question to answer because it does depend on your heating demand. So if you know, you can do the maths. If you say we charge at about 10 kilowatts, it takes us about four hours to get to full charge. And if you're using you know, 3-bed house might use 80 kilowatt hours on a cold day, then we need 2 full charges a day. So we need about 8 hours of electrical input, so we can be off for about two-thirds of the day. I think that was the question.
Okay, perhaps James, you could answer that question a bit later, maybe. Another question for Johan. Oh, it just moved. What are the ZEB's daily heat losses?
So again, this depends on the state of charge. It's sensible heat storage. It does depend on the state of charge, and that is a function of we will only ever put enough charge to provide the heating that's needed for the day. So it depends on the time of year. So I'm getting a bit of feedback there. The other thing I would say is that it's in the house. So old night store boilers were actually included in the SNAP, and they are still in SNAP, and they are defined as 100% efficient. And that's because electric resistive heating is 100% efficient, and when the unit's inside the heating envelope, any losses go into the heating envelope. But if you assume those are actually losses, which they're not, then the annualized efficiency is about 93%, based on a 2-bed home, using about 15,000 kilowatt hours of heating a year. So it does depend on the state of charge.
Thanks, Johan. Right, we'll give the speakers a bit of a breather. I think we actually have got some. Is there some? Dan, is Dan Edith? I think you may have yourself off. Oh, thanks, Dan, for taking yourself, muting yourself. That's better. Okay. Sorry, I was about to say that we can give our main speakers a bit of a break for a few minutes, and then we'll go on to the question and answers and try and widen it out a bit as well, some of the questions. But our last speaker is Claire. Sorry, I don't have my notes in front of me, Claire, so I've forgotten your last name, but Claire from Woodvine, who is going to speak for a few minutes. Thanks, Claire. I think you've got one slide. Did you say you had?
I do just have one slide. If I can put it up, let me just see if I can share it with you.
Just whilst you're doing that, Claire, thank you for speaking today. Claire is from Woodvine Solicitors, who are an associate founder member of Cambridge Cleantech.
Hold on a minute. Let me just stop sharing that. I can do it without screen sharing. It's not really too much of an issue. I just really wanted to say thank you for letting me gate crash your presentations. It's been really interesting for me, not only as a lawyer but also as a homeowner, to see what's happening in the market, and it's been really interesting. So thank you very much for the time and letting me have a little chat to you. I literally just wanted to give you some idea of Woodvines as a firm, and also just to let you know that we are in your space. We've been sponsors of the Cambridge Cleantech for a number of years now, for 3 years actually. And we also sponsor the Cambridge Independent Entrepreneurial Science and Technology Awards. But we are a regional firm, and we cover the Oxford-Cambridge arc, and we are a full service firm. So we offer services to businesses like yourselves in the SME market, and also to individuals. So we kind of pride ourselves on providing straightforward, simple legal advice to SMEs, and we're quite well known in the area, and we offer quite competitive services as well. I just wanted to introduce you to a particular team within Woodfinds, which is the corporate commercial team, which you might be able to find use for. So it really is just an idea. I've been listening to you, looking at perhaps your early stages, or perhaps looking at investment. It was just really to give you an idea of the fact that there is advice out there for you, that we are available if you wanted to come and talk to me or us as a team. And that really doesn't mean that you would have to engage us as such. I'm quite happy for you to just pick up the phone and say, I'm not quite sure about this, because what I'm listening to is that you are absolute experts in your area. But where I come from is that I've been a lawyer for a number of years now, both in private practice and in-house. And what clients and other stakeholders that I've acted for in the past, they're very good at their side of the business, and it's important that they concentrate on that. But also I do hear often they want to instruct people to do the work that they can't do themselves. So it wouldn't be right for me, for example, to offer VAT advice to you, but I know some very good accountants that could do that for you. But at the same time, there are some perhaps legal issues that you might be facing that you perhaps don't have the skill set within your smaller companies at the moment to do or to deal with, and that you just need a sounding board, or that perhaps you might need some advice. Where I think that we might be able to add value is especially when you are getting to that investment stage. There's just some things that I wanted to flag to you, is that it would be, you might need some help. You might be perfectly fine at it, but you might need some help in actually just getting to that investment stage, i.e. get your ducks in a row. And sometimes I come across some companies that have amazing ideas, but when it comes to the investment, and I've acted for VCs and private equity houses in the past, when it comes to the actual investment, getting the money in, which sometimes can be a bit crucial, is delayed because VC houses have their in-house legal function, or they have lawyers like me, and we are looking at all sorts of things to make sure that the investment is sound for our particular clients if I'm acting for the venture capital. So there are ways as well that we can help you get to that stage quicker. The typical things that lawyers would be looking at is to make sure that the company is incorporated properly, to make sure that if you have a shareholders agreement in place, that it's being controlled, or you're using it effectively, i.e. you've issued shares in the right way. If you have growth shares, that you've offered those growth shares to the right people. You've actually issued your shares. We've had that before. You know, there are things that we could help you with in order to kind of sense check your company, if you like, before it gets to investment stage. Another thing as well is making sure that, and I was just going to talk about 3 things, but there's a lot more than 3 things, but just 3 things is make sure your ducks are in a row when it comes to the corporate documentation side of things, because someone like me would be looking at it. Also, make sure that your intellectual property is there, i.e. if you are developing your own IP, then make sure that you have patent attorneys looking at it, and that you've made the filings, that your trademark is registered, and that you actually own the intellectual property. And sometimes that can be a bit tricky to ascertain, especially if you have the right to exploit IP from other suppliers or other entities. So that's something that we would always look for as well. And then the last thing really is just making sure you have that contractual strength. So when you are dealing with suppliers, when you are looking at contracting with other individuals, businesses, or for example, if you're looking to end user, that you do have those good contracts in place, because certainly with COVID, we've noticed that force majeure might come into play. There are companies that you thought may have had good standing, and that they are suddenly not such good standing clients or good standing companies. So really, it's just to kind of think about those things, especially if you are seeking investment at the moment, and or just generally looking at creating that solid base upon which you can then launch to get investment. So me and my team would be more than happy to have a chat with you at any point, and talk about things with you, even if it's just a consultation to begin with. We're more than happy to do that. Our background, as I said, is kind of corporate and commercial. We offer both services within our team. We're quite a small team, and we do cover, and we know quite a few contacts in our area, the area that we all operate in. So do pick up the phone to us, do contact us if you do want to have a chat. We're more than happy to help. And that was my 5 minutes, and I just really wanted to say thank you for letting me gate crash.
Thanks a lot, Claire, and some very kind of initial, very useful initial advice there, which is great. And with that offer of maybe a little bit of 10 minutes of free consultancy before you start.
Oh yeah.
Not timing, of course.
Yes, absolutely, no problem.
Thanks a lot, Claire. Okay, right. If we could have our three main speakers, back and unmuted for now. I think if we can we get them, Ariane? Can we get them all four of us on the screen? Just trying to sort it out. And I'm going to start off, and this is going to be more a general question to start off with for everybody. And then I've got quite a lot of kind of questions come through, which I'll try and whiz through in a moment too. But I've got a couple of questions. I think what we'll do is we'll have about 15-20 minutes of question and answers now. And then if we don't, as I said, if we don't have time to answer your question that you may have already sent, we'll then have breakout rooms, let's say, I think about 5 to 6, and then we'll aim to finish the breakout rooms at 6:15. In fact, it'll be a hard stop at 6:15 because I have to go and pick up my son from the railway station. So first question actually was raised by Salvatore, but I think it applies to everybody. And I've experienced the issues here as an energy assessor going around people's homes. Occasionally I do come across some really kind of weird and but very interesting new systems, like I do recall one which was an electric heating system which operated. One of the biggest problems which appears to exist for people who are doing energy assessments is a large number of these new solutions are not available in the categories which are allowed for when you're doing an energy assessment. So what I'm asking all three speakers is, are you starting to actively look at how can you get your solution included as a new solution for the so that when somebody comes along and has to do an energy assessment of a property to get a rating for it, your solution will be included within that. Let's start off with James.
Okay, so I think Johan probably can give more detail on this because I know he's been more involved with it, but within SAP we come under the category of what's called a dry core boiler, which was a bit of technology made by GEC in the 70s and 80s. It was a very large night storage heater that then had a heat exchanger to go into a wet heating system. Having said that, I think the bigger concern I have is that SAP still is very retrospective looking. So it looks at the carbon intensity of electricity, a few years back, and they have changed it and made electricity less carbon intensive than it was in the previous SAP. But the reality is you put in a heating system for 10 or 20 years, and we know that within 10 years, the carbon intensity of electricity will be, well, off peak. I'm expecting it to be below 50 grams per kilowatt hour CO2. And it's crazy when people are making decisions for the future that we're looking at past electric intensity, whereas gas is going to have the same carbon intensity in 10 years time as it does today. So I think SAP needs to get much more proactive and progressive in terms of how it treats electricity.
Johan.
Nothing more to add. James got it spot on. Yeah, it's covered in SAP. Yeah, so
Christine?
Yeah, I think I alluded to it a little bit in my presentation, that whilst we're bringing through the technologies and the innovation, it's the whole supply chain that we need to bring with us. So right through from who trains the installer, who accredits their workmanship, and that whole route to market. And I suppose that's why we kind of looked at, especially with our early pilots and early customers, it's not just looking at getting the innovation and the new technology out there, it's getting the business model and how it actually, we get it to the end customer, and give them the security that we're giving them something that has been accredited and approved. And what I would say, it's not going to be easy, but I think digitalization can help us a lot here. So, you know, if we can put digital technology or digital monitoring and testing within the solutions that we're providing, and that gives assurance, and it gives accreditation, makes accreditation easier along the whole chain. It's something we're going to have to learn. It's not going to, you know, it's a challenge that we're going to have to go through. But I think at the foundation of bringing all of these technologies to market, it's key.
Yes, yes. Okay.
Sorry.
Johan, yeah.
Sorry, Peter. I was just going to add just very, very quickly on SAP, because it can be a very long topic. One of the key, and Jane touched on a couple of the issues with SAP, but one of the key things, as far as I'm concerned, and I know it's been looked at, is that SAP is very much focused on the house as an island. In the new energy system, to get to net zero, we can't have the house as an island. We have to consider it as part of the energy system, and it's an absolutely essential component. You know, and to properly value basically flexibility and storage, and whether that's whatever type of storage that is, or thermal or chemical or whatever, and that's absolutely essential. And it comes back to what Christine was saying as well. That was all.
Yeah. But I think it's still a case of that you would all need to, and any other new innovative heating systems that come along will need to kind of lobby the building research establishment and lobby BEIS to do this. Because going back to that example I gave, you know, and that's 2 or 3 years ago now, I think it was, I went round to this property, and it's a rented property. And it ended up being an F-rated property because it was using an electric heating system, which I knew was a modern new electric heating system. But because of the arrangements that which existed, and an energy assessor can't change things independently, any energy assessor has to follow a set of rules to do this. And in fact, I did lobby with my certification body in this case, and they actually then, and the head of certification from Stroma, as it was in my instance, actually went and took this up with the various bodies, committees, but he still couldn't actually get that changed. Despite it being a modern electric heating system, it was considered to be under a certain category, which resulted in it being an F-rated property, and that was a private rented property, which basically means it is now illegal for that property to be let out. And as far as private rented properties are concerned, there is consultations coming out at the present moment which talk about private rented properties being a D rating by 2025, and then being a C rating by 2027, I think it is, 28 I think it is. So it's very important that any new technologies actually make sure they kind of, you lobby to get them included as an innovative and efficient kind of system compared to old systems in that respect.